Hi, and welcome to AP Chemistry Review. It's me, Dr. V, and I'm here to help you get ready for the AP Chemistry exam in May. Today we're working on free response question number 4 from the 2018 exam. So before we get started, the 2018 question number 4 was one of the short free response questions, which is recommended to take about 8 minutes, although it might take you a little bit longer, and it was scored out of 4 points. Before you listen to the rest of the webcast, I do recommend that you try to work through the problem on your own. You'll need your calculator, a periodic table, you'll need your formula sheet. But that's always the best strategy for listening through these webcasts. All right, and then keep track of your work as you go. Certainly try to do each part before you listen to my explanation. So let's look at part A. In terms of the types and relative strengths of all the intermolecular forces in each compound, explain why the boiling point of carbon disulfide, which is a liquid, is higher than that of COS. Okay, so here's what we need to do. We need to look at the molecular structures. We're given a depiction of the formula and their boiling points. And it was scored out of 2 points. So here's what you need to recognize. Carbon disulfide is a nonpolar molecule. If the carbon-sulfur bond is a little bit polar, those bond dipoles point in opposite directions, so the sum of the bond vectors will be 0. So it is a nonpolar molecule. And so because of that, the only intermolecular forces it can participate in are London forces. That's all that nonpolar species can do. COS will be a polar molecule. The bond vectors certainly won't all be the same for those polar bonds. They won't add up to 0. So it is a polar molecule, and therefore, not only can it do London forces, but it can also do dipole-dipole attractions. So you need to be able to list out what intermolecular forces each one can do. I probably wrote here more than I needed, but I was trying to just be very thorough. When you're working in a time situation, all you needed to write down was the intermolecular forces for each species. CS2, you're told, has the higher boiling point. A higher boiling point means the intermolecular forces are stronger, regardless of what they are. All right, and so what that means, and what you need to write down in terms of your answer, is that the London forces of CS2 have a stronger net effect than the combined intermolecular attractions of COS, which are the London forces, and the dipole-dipole attractions. So these 2 bullet points on the right are really all you needed to include in your answer. You got 1 point for correctly stating the types of intermolecular forces in CS2 and COS together to get the point. And the second point was for saying that the London forces of CS2 must be stronger, and we know that because its boiling point is higher. All right, let's go on and look at part B, which is a completely different question. Well, I guess it does involve CS2, but it's in terms of what the question asks, totally different. A 10-gram sample of CS2 is put into an evacuated 5.0 liter container. It's sealed and heated to 325 Kelvin, where all of the carbon disulfide has vaporized and turned into a gas. What's the pressure in the container once all of the carbon disulfide has vaporized? Okay, so we've got gaseous carbon disulfide. We know a volume. We know a temperature. We actually know the mass of the sample, and if we know mass, we know moles. This question was scored out of 2 points, so here's what we need to do. All right, we need to find the pressure, which means this is an ideal gas law pressure, PV problem, PV equals nRT. All right, so the first thing we're going to do, I'm going to do is calculate the moles, right? You need the molar mass of CS2 and calculate as 0.131 moles. And then I'm going to substitute that into the ideal gas law, which I always like to rearrange before I substitute in because that's always a good strategy. You're less likely to make mistakes. So I can substitute in my value for moles. I need to use an appropriate value for R. I use the one that involved liters and atmospheres and moles in Kelvin instead of the one with kPa. But I could have done that as well. That would have been fine. The temperature we're already given in Kelvin, and then we need to divide by the volume in liters. Of course, you could substitute in your mole calculation here. This was scored out at 2 points. You got 1 point for correctly calculating the moles of carbon disulfide, and 1 point for getting the pressure correctly with an appropriate unit. Right, so we get an answer of 0.70 atmospheres. We do want to pay attention to our sig figs. Since the volume only had 2 sig figs, our final pressure should also be reported with 2 sig figs, and that's really what the question needed. Pretty easy as far as what you need to do for the problem. All right, how did you do? The 3 out of the 4 points were fairly straightforward to get. Identifying the intermolecular forces, doing the ideal gas law problem. The average score on this question was 1.87 out of 4. So most students got either 1 point for part A and 1 point for part B, or got 2 points, I think, for part B is my guess. I wasn't there, but that was that's my gut feeling based on what I've seen from my students. Don't forget to subscribe to my channel.